Hey guys, welcome to the channel. My name is Ethan Mitchell, and today I have an FPV build for you. I typically do drone reviews and tutorials, so if that's something you're interested in, consider hitting the subscribe button along with the bell, and you'll be notified when I post new content. Today we're going to build this. This is an Armattan Rooster with the DJI FPV HD system installed. Now the DJI system does not fit in a stock Armattan Rooster frame. So we're going to do some modifications to make this work. Now this is going to be a two-part video. The first part will go over the conversion process and what I did to convert this into a digital quad. And then for the second part, we'll take it out in the field and give it a quick tune and see how it flies. Now the DJI Air unit does not fit into the Armattan Rooster frame, but today we're going to do some mods so it works. Okay guys, let's do a quick run through of what we have. This is an Armattan Rooster 5-inch frame. We have a Brain FPV Radix flight controller. Underneath we have a 4-6S 35 amp Racerstar 4-in-1 ESC running BLHeli-S. We have a FrSky XM Plus receiver, Wolf Whoop VTX, Runcam Eagle 2 camera, and the motors are Emax 2306 2400 kV motors running on 4S. And we also have some 3D printed parts for the antenna and the GoPro mount. Okay. So we're going to keep the flight controller and the ESC, but we're going to pull the receiver, camera, and VTX, and we're going to switch the motors out so we can run 6S. So let's go through the parts we're going to put in. All right, so we're going to upgrade the receiver to a Crossfire Nano. We're also going to put in a Zing 2208 1800 kV motors so we can run 6S. We also have a DJI Air unit. Now the DJI Air unit will not run on 6S voltage, and the Radix flight controller does not have a stepped down 12 volt or 9 volt pad, nor does the 4-in-1 ESC. So we're going to have to use a step down voltage regulator. And for that I have a Diatone 12 volt 2 amp voltage regulator to power the DJI Air unit. So let's go ahead and pull everything out that we need, and then we'll go through the modifications. Okay, now that we have everything out that we're going to convert over, let's go over the modifications we're going to have to do to the frame in order to make this work. So the Rooster frame has the arms mounted above the bottom plate. To make this work, we need this back area totally flat. In order to get a flat base, we're going to have to relocate the arms to be underneath this bottom plate. Now we're going to do that to the front arms as well so everything matches up, but that's going to drop the camera cage about 4 millimeters. And for that I made a 3D printed spacer so the top plate will be the same height. Okay, let's go ahead and move the arms. Okay, now that we have the arms mounted on the bottom, I want to go over what I did in order to make this DJI Air unit work. Because as you can see, if we put this Air unit in here, it's going to be up tight. It's pushed up tight to the ESC in order for it to fit, and it's still a little too big. Ideally, we need to have the DJI Air unit about right there. So I made some 3D printed parts in order to extend the back of the drone in order to make this work. We've got a 3D printed part right here, and that's going to go on the back. And also I have 2 3D printed plates, and basically they're going to sandwich in like this, and we're going to bolt them up, and they're going to extend the back of the frame just enough in order to make this work. All these parts are made out of TPU, which is fairly flexible, but it can also be extremely stiff if you print it solid. This one's got about, I think, 20% infill, but the plates have been printed solid, so they are very rigid. This back plate I made with the holes large enough so we can slide in a 25 millimeter standoff for extra rigidity. I've also made this to take a SMA to MMCX connector. All right, so let's start putting this together, and first we'll start with bolting up the motors and getting those wired up. Okay, now that we have the motors all bolted up, let's run the wires. And there it is. So all the motor wires are all wired up. I'm not going to tape them down yet just in case I got to do some changes. So now let's take a look at the flight controller. So let's run the wires for the Crossfire Nano. So the only thing we have left to wire up is the DJI Air unit. Before we wire up the Diatone voltage regulator, what I'm going to do, we're going to fit this Air unit into place and kind of get it all mounted up, and that way we know where we want to mount the voltage regulator. We're going to run the camera wire in between the flight controller and the ESC. What I'm going to do first, we're going to go ahead and mount the camera up. So the camera's got a little arrow on the back that'll tell you which way it goes up, but you can also reverse that in the goggles if you need to. I've also made these 3D printed TPU spacers for the camera. There's a left and a right. You'll want to put the spacers on first, and then we'll mount the spacers to the cage, and then we'll slide everything on together. Okay, so now we need to have a screw that'll come through the cage, through the TPU, and then we're going to put a nut on the back. So we're going to be using 12mm M2 screws, and then we're going to use an M2 lock nut on the other side. Okay, we've got the camera all bolted up into the cage, and if you could see, that's what the back looks like. And so now we'll go ahead and bolt up the camera cage. Now let's work on the air unit. So we're going to take our TPU printed parts and get all this bolted on. This rear TPU plate I made so it'll take the SMA antennas, and also I can slide through a 25mm standoff and make this part really rigid. So this bottom plate's going to go on like so. So I'm going to bolt these on with 10mm M3 screws and a press nut on the bottom plate, and we're going to use 8mm M3 screws on the top plate. See, now the air unit has enough room to fit in there even with the antennas mounted on the back. So, all right, so that's that part. Let's put on the SMA pigtails. All right, so that's what it's going to look like, just like that. And it pushed right up against those back of those antennas where they go in. That way, if you have a crash, they don't pop out. Everything's wired up to the flight controller except for the DJI cable. So let's work on that right now. If we look at the DJI manual, obviously red is your power, ground. We are not going to use the yellow or the brown. They are for if you're using like S-Bus, or if you're going to be using the receiver that comes in the air unit. We are going to wire up these two wires to a UART on the flight controller. That way we can change the PIDs, we can get the OSD working. That way we can start recording when we arm and all that jazz. All right, so that's wired up. And now we got to do the power. Okay, so first, so let's see where we're going to put the Diatone voltage regulator at. So you can see there it is. It's very small. It's about the same size as the Crossfire Nano. And so I think I'm going to run the Crossfire right there. And then we're going to put the voltage regulator right next to it. I'm going to have the wires, the VBAT coming in. We're going to come in from this side, and then we'll have the voltage going out that way to the air unit. So I will say it is a pain in the butt having to use a voltage regulator with, if you want to use 6S. And it is going to be much easier if you get a flight controller that has a pad that puts out 12 volts or 9 volts with the correct amount of amperage. But, I really like this frame and I really like this flight controller. So I'm going to go through the extra steps I need to do to, make this work. And now we're at a stopping point. Before I plug in this air unit, I'm going to plug in a battery, double check this voltage regulator, and make sure it is outputting 12 volts. If the DJI air unit, for whatever reason, gets more than 17.6 volts, it will be damaged and you'll probably have to get a new one. And these are not cheap. So the voltage in is okay, that's 6S, 24.9 volts. And the voltage out is 12.1. So we're good. So we are good to go. So we're going to wire the DJI air unit power up, get it plugged in, and then get the shrink tube on and start work on getting this thing buttoned up. Okay, I'm going to take off this rear standoff and basically flip the whole DJI air unit up, and that way I can put some very high bind tape on the bottom, and we'll also get the harness plugged in. We're going to plug a battery back in, make sure the air unit's getting power. we got a red light there, and it's turning to green. So we're going to push this little pin in and bind it. So I'm going to power on the goggles, and now we will press the bind button on the goggles. And we are good. So we have video, but the goggles are telling me that it's not activated. Okay. So now I know the air unit's working, we got power, everything's working well. So we're gonna button this up, and then we will head over to Betaflight and get everything configured. So, crossfire antenna is on, Radic stack is in, voltage regulator is in, the Crossfire Nano receiver is mounted underneath. And so let's go ahead and put on the top deck, and then we're going to put on the GoPro mount that has the GPS module in it. Now the top deck, I've already installed the TPU plate, and we also have to put in the spacer. So the spacer is going to go on the front just like that. Okay, so that's what it looks like. Okay, all right, so let's do the 3D printed GoPro mount. Okay, so this is the 3D GoPro mount that I made. You can see that it holds the GoPro relatively well. It's pretty low profile. With the Rooster, it comes with this top plate that mounts here. What this plate's going to do, it's going to slide inside that slot right there, and then it can mount up. Goes on like so, like that, and then we'll mount it up. Now the GPS chip will just slide into this slot like so, and we are ready to go. All right guys, so there you have it, the Armattan Rooster with the DJI FPV system installed. Stay tuned for part 2, where we're going to take this out and put a quick tune on it and see how it flies. As always, thanks for watching. If you have any comments or questions, comment below. And if you like this video, please give it a thumbs up. Have a great day. We'll see you next time.